All right, this is number 5 on the angle line problems that we did on Thursday. And so what we're going to do, I have the types of angles that we learned about the other day. So we have corresponding angles, which would be, we have two parallel lines here. So my corresponding angles, for example, I have a transversal here, so I have a corresponding angle here, this angle, and this one. Those are corresponding angles. Alternate interior angles are in here, so I have this transversal here, I have an alternate angle here, and one right here. Those are also congruent. Finally, I have alternate exterior angles. For example, if I was looking at this one, I see that this one and this one are on the opposite side of the transversal, and they're outside of the parallel line, so they're alternate exterior angles. Then there is a pair of same side interior angles right here. Okay, so I need to know those things. When I'm doing these problems, those are what I want to be looking for. Okay, so they don't give us a whole lot of information here in this problem, but what I see in this problem is that there is actually a corresponding angle hidden somewhere in here. And what it actually is this second line is confusing us. So I see one angle right here. So this is the one angle that's easy to see. Okay, my corresponding angle, so I have my two parallel lines. My corresponding angle for this line is actually this angle right here. This big angle, okay? So don't get distracted by the split here. So this transversal is actually just a distraction. The corresponding angle to this angle right here goes along with this transversal, and it's actually right here, okay? So this big angle, the combination of these two angles make the big angle, okay? So using my angle addition theorem that we learned maybe the first or second week of class, I know that the measure of this whole big angle here, this whole big angle, is really actually 2x plus 50. Is really 2x plus 50. Okay? So that is the whole angle. Now, I know that I have two corresponding angles, so I have one right here, one right there. I know that corresponding angles are congruent. When I say that something is congruent to something else, that means that they are equal to each other. So if I am now translating that into algebra, so we're going from geometry to algebra, I want to say that 5x minus 16 is congruent to this. I'm going to say that they're equal to each other. So what I'm going to do to solve this problem is I'm going to say that 5x minus 16 is equal to, they're congruent to each other, is equal to 2x plus 50. Once you get to here, you just have some basic algebra. So we're going to add 16 to both sides, get 5x equals 2x plus 66. We're going to move this 2x over because we want to get x by itself. 2x, this gives me 3x over here equals 66. If you need a calculator to do this last step, we're going to divide by 3 on both sides, so I end up with x equals 22. Okay? So the trick in this one is to understand that even though this angle here is split, this big angle here is split, we can still add the two little angles together to find the overall corresponding angle. Okay? So the trick for this one is to recognize that there is a corresponding angle hidden here. And really the easiest way that you can start going about these problems is to find one of the angles, and you should know that there should be a corresponding angle, an alternate interior angle, an alternate exterior angle, something like that somewhere in here. So that's what I started by. I saw this angle here, and I said I'm going to look for a corresponding angle. And I knew it was right here. It happened to be where they gave me information, so I was able to use that information to solve the problem.